Factoring binomials and perfect square trinomials. Even if your factoring skills are good, review this section to learn how to solve some of the more difficult questions found on the SAT. In this section, you will learn how to square a binomial to get a perfect square trinomial, recognize common perfect square trinomials, and find missing constants when given a binomial squared and the perfect trinomial that's the product of squaring that binomial. Basic information about binomials and trinomials. A binomial has two terms. Examples are x plus y, x minus y, x plus 1, x minus 1, and 2x plus 3. If you square a binomial, multiply it by itself, the result is a perfect square trinomial. One technique used to square a binomial is called FOIL, an acronym that stands for first, outer, inner, last. The first term of a perfect square trinomial is a perfect square. The last term of a perfect square trinomial is also a perfect square. The middle term of a perfect square trinomial is always even. To find the middle term, take the square roots of the first and last terms, multiply them together, and double it. If you are given a binomial and want to square it, remember the jingle, square the first, square the last, multiply the two together, and double them fast. Note that the doubled product becomes the middle term. Squaring a binomial gives a perfect square trinomial. Example 1, find x plus y quantity squared. Square the first term. The first term is x, we square it, the product is x squared. The last term is y, squaring y gives y squared. Multiply the two terms together, xy, double them, that becomes 2xy. That 2xy goes in the middle, and the perfect square trinomial is x squared plus 2xy plus y squared. Example 2, square 4x minus 3. We square the first term. 4x times 4x is 16x squared. The last term squared is negative 3 times negative 3, which gives positive 9. We multiply the two terms together, which is 4x times negative 3, which is negative 12x. Double them, and we get negative 24x. The trinomial becomes 16x squared minus 24x plus 9. Remember that a perfect square is formed by multiplying the same term by itself. 9 is a perfect square as it is the product of multiplying 3 by itself. 16x squared is a perfect square because it is the product found by multiplying 4x by itself. X squared plus 2x plus 1 is a perfect square trinomial because it's the product of multiplying x plus 1 by itself. X plus 1 times x plus 1 gives x squared plus 2x plus 1. When is a trinomial a perfect square trinomial? When the first term is a perfect square, the last term is a perfect square, the middle term is even, and the middle term is twice the product of the square roots of the first and last terms. As a general rule, if the first and last terms are perfect squares and the middle term is even, the trinomial will usually be a perfect square trinomial. There are exceptions, but they are rare. Is x squared plus 8x plus 16 a perfect square trinomial? X squared is x quantity squared, hence the first term is a perfect square. 16 equals 4 squared, hence the last term is a perfect square. The middle term, 8x, is even. If we take the square roots of the first and last terms, x and 4, and multiply them together, we get 4x, which, when doubled, gives 8x. Hence, x squared plus 8x plus 16 is a perfect square trinomial. Common perfect square trinomials include x plus y quantity squared, which gives x squared plus 2xy plus y squared. X minus y quantity squared equals x squared minus 2xy plus y squared. X plus 1 quantity squared equals x squared plus 2x plus 1. X minus 1 quantity squared equals x squared minus 2x plus 1. If you memorize these perfect square trinomials, they're very common on the SAT and you'll save yourself a lot of time. Two common perfect square trinomial problems on the SAT are problems in which you are asked to find missing constants in a trinomial, and problems in which you are asked to find a numerical value for a trinomial. Example 4. Given x squared plus kx plus 25 equals x plus b quantity squared, find b and k. Because the trinomial is set equal to the square of a binomial, we know we have a perfect square trinomial. To find k, we know that the middle term is twice the product of the square roots of the first and last terms. Find those square roots. The square root of x squared is x, and the square root of 25 is 5. Since all the signs in the trinomial are positive, we are working with the positive square root of 25 only. To find the middle term, multiply those roots together and double them. 2 times 5x equals 10x, and recall that k is the coefficient of 10, therefore k equals 10. To find b, take the square root of the last term of the trinomial. Because everything is added in positive, we work with the positive root only. The square root of the last term of the trinomial is 5. This must be b. Example 5. Given that x squared plus y squared equals 100 and xy equals 10, what is the numerical value of x plus y quantity squared? Remember what x plus y quantity squared is equal to. It's equal to x squared plus 2xy plus y squared. We already know that x squared plus y squared equals 100. We need to find the 2xy. Since xy equals 10, then 2xy equals 20. Add the two numerical values and get 120. Here are some practice problems for you to try. Pause the DVD after each problem. When you have finished solving the problem, come back for the answer. Problem 1. Find k and b when x squared plus kx plus 9 equals x plus b quantity squared. Answer to problem 1, k equals 6 and b equals 3. Recall that if you square a binomial and if you square x plus b quantity squared, the result is x squared plus 2bx plus b squared. Compare that to x squared plus kx plus 9. Therefore, b squared equals 9 and b equals 3. Another way of thinking about this is the form of x squared plus kx plus 9 equals x plus b quantity squared. That tells us that we have a perfect square trinomial, which is the product of a binomial squared. Therefore, b is the square root of 9, which is 3. The middle term, kx, is equal to twice the product of the square roots of the first and last terms. The square root of x squared is x, and the square root of 9 is 3. 2 times 3x equals 6x, and k equals 6. Problem 2. Find k and b when 4x squared plus kx plus 121 equals 2x plus b quantity squared. The answer to problem 2 is k equals 44 and b equals 11. To find b, take the square root of the last term of 4x squared plus kx plus 121. The square root of 121 is 11. To find k, take the square roots of the first and last terms of the trinomial 4x squared plus kx plus 121. The square root of 4x squared is 2x. The square root of the last term, 121, is 11. This is b. Multiply the two square roots together. This gives us 2x times 11, which is 22x. Double that product. 2 times 22x equals 44x. Hence, k is 44. Problem 3. Find a, b, and k. A plus b quantity squared equals 25x squared plus kx plus 36. The answer to problem 3 is a equals 5x, b equals 6, and k equals 60. Recall that a plus b quantity squared equals 25x squared plus kx plus 36. A equals the square root of 25x squared, which is 5x. B equals the square root of 36, which is 6. Kx equals 2 times the square root of the first term times the square root of the last term. Kx therefore equals 2 times 5x times 6, which equals 60x, and k equals 60. Problem 4. Given x squared plus y squared equals 17 and xy equals 4, what is x plus y quantity squared? The answer to problem 4 is 25. Given that x squared plus y squared equals 17 and xy equals 4, what is x plus y quantity squared? Just restating the problem so you can follow the work. Recall that x plus y squared equals x squared plus 2xy plus y squared. If xy equals 4, then 2xy equals 8. Since x squared plus y squared equals 17, the value of the entire trinomial is 17 plus 8, which equals 25. Problem 5. If a squared plus b squared equals 25 and ab equals 15, what is a minus b quantity squared? The answer is -5. Recall the problem. If a squared plus b squared equals 25 and ab equals 15, what is a minus b quantity squared? A minus b quantity squared equals a squared minus 2ab plus b squared. Since a squared plus b squared equals 25 and negative 2ab equals negative 2 times 15, which equals negative 30, add 25 plus negative 30 for a sum of negative 5.